folks, welcome, and welcome out there. It's a Friday afternoon with a great specialized segments coming your way today. I am glad you've tuned in. This is one of those days where you don't get to call in. We don't worry about the phone number. However, we'll be back live on the air Monday, Tuesday, Wednesday, Thursday next week, and we'll be back in action and be able to answer your questions. In the meantime, I am Ernie Roberts. This is TNLearn Mathline. And if you would like to send us some questions, feel free to do that on our Facebook, on our email. But right now, get you a pen, get the paper, pencil, whatever you need to write with, and maybe a calculator. Maybe not. We'll go for it. And let's do some math, all right? Sit back, relax, and let's do the math. Let's see what our show's about today. How about it? Let's see what we've got coming our way here. It says there seems to be an app for everything. App, in this case, is going to be an application. And, you know, maybe there is, maybe there isn't an app, but we love to think that everything we do has a purpose and such. So here are some ways that we are going to look at using inequalities today and being able to take care of things, all right? Solve a few and apply them to some real world situations. Hence, there may be an app for everything, all right? Let's take a look at, first of all, let's go back and review just a little bit on the inequalities, make sure everybody's in good shape on that. Just look at some simple, straightforward equations. No, not equations this time, they're inequalities, all right? So, let's distribute. The procedures and the principles behind what we do to solve these are fairly similar to what we do for an equation, all right? So let's go ahead and take a look at this first one. We're going to distribute. We're going to use the distributive property, and we're going to move this thing pretty quick, all right? Again, called review. Those of you who are just tuning in, don't get discouraged. I'll still keep going with you. We're going to double everything in this parenthesis because this is let's multiply by 2, all right? So we got 2 times 3, which is going to give us 6a. We got 2 times the minus 8, which is going to give us minus 16. And you know what? We get a 20 out here. Good job, all right? So basically, we just doubled everything. By the way, that is a 6a, not 64, or something like that. You know, so many times these letters try to become numbers. You know, they just want to be. They're variables, but we're going to eventually find something that a can be. But right now, we're going to leave it as a, all right? Just leave it as a. Here's the deal. Let's add 16 to both sides. That works pretty nicely. And let's see where it's going to take us. It's going to give us 6a on the left. And on the right, we're going to have 36 on 36. And divide by 6, both sides by 6. Life should be good. And we got a greater than value of 6. Now you say, Ernie, what does that mean to us? It means any number bigger than 6 will make this true. So if we put the number 6, by the way, in here, that would make it equal. And we're not wanting the equals to situation here. We want it to be greater than. So basically, we're saying any number bigger than 6, be it 7, 6 and a half, 6 and a quarter, any number, fractions, decimals, percents, integers, all sorts of good things. As long as they're greater than 6, we're good. All right, now percent would need to be, well, you know, 600% maybe or whatever, but you get the idea. When we're talking about our fractions here, mixed numbers, I should say, that would be much better. But when we use our mixed numbers or mixed decimals there, as long as they're greater than 6, the value is greater than 6, it's a good answer. It's a good answer. So if we were going to number line that, which we're not today, we would have an open circle and shade it to the right. Okay? Let's take a look at another problem here. And I'm going to rewrite this thing. I'm going to bring it over here a little bit and let you all have a chance to write it also. And make this a little bit better. Sometimes when we want to do fractions with the good old computers, sometimes the division sign almost looks like a vertical slash almost there, but this one is actually meant to be 3x plus 5 divided by or over 4, and we're going to say it's less than 2x. Now we're good. Now we're cooking, all right? Let's do the thing. Let's get to go ahead and multiply. Clear your denominator here. Multiply both sides by 4, all right? And that's going to leave us with, on the left, 3x plus 5. Notice, didn't change. The 4's canceled, so you just use 3x plus 5. That's what's left over. On this side, however, nothing's canceling. So we're going to have less than 8x. Now, questions of questions of questions. Which way do we go on this, right? Yep, everybody's wanting to know. I'm going to go ahead and subtract 3x on both sides, all right? It's going to leave me with a 5 over here and a 5x, which was nice to happen over here. And then we're going to divide by, it's a positive 5, so we're going to divide by 5. And what that basically tells me is that we're going to get, let's see, we're going to have 1 less than x. Now, some of you are saying, does that mean all the numbers, if we were open circle on one, or are you going to shade left? No, no. What this means, folks, what this means, we like to write it the other side, is that basically we're looking for numbers that are bigger than 1. All right? If you put a number bigger than 1 in here, it's going to make this side become the greater side. All right? It's going to make this thing less than. You say, is that real, Ernie? Are you sure? Well, first of all, put a 1 in here, I've got them equal, right? So let's go for a number like 2. 3 times 2, y'all got that? 6 plus 5. And 6 plus 5 is 11, which is less than 16. So again, that's one nice thing about pick a number that's bigger. Pick a number that's bigger there. Pull it in there, check and see, do you have the true situation? And you should have your inequality going in the right direction, all right? And that, again, just helps us when we just kind of square it up a little bit, turn it around there. It's nice to have it to work for us. Now, let's take a look at our first example here. -4 times a number added to 5 is at most 13. First of all, what does at most mean? That means it's a limit. It can't go above, but it could get to 13, all right? It can hit 13. It's got to be 13 or less, all right? So let's see, first of all, let's set up a variable. We're going to let n equal the number that we're looking for, okay, that number that's going to make this work. And actually, it's going to be a lot of numbers that make it work, all right, because it is an inequality here. Let's see, -4 times that number. All right, so let's go with -4 times the number. It's just like writing an equation at first here. Added to 5. And I'm going to go with the fact that it sounds like to me we're going to say -4 times the number and then add that to 5, all right, rather than trying to put a parenthesis around here. Some of you may want to think differently on that, but let's go with this. Now, moving along here, it says at most. And what we're saying, folks, is how does that relate? Well, it could be 13, but basically we want it to be no higher than 13. So that's going to make this less than or equal to 13. Now, sometimes people see at most, they think, well, that's got to be greater than because it's talking about most. No, it's talking about how high you can go. And you've got to have this quantity over here has got to stay below or equal to 13. That's the game plan. So let's find out what the game plan is going to give us. How about it? Let us subtract 5 from both sides. There we go. I see a -4n. You see a -4n. We all see a -4n. That's all that's left over. Be sure that negative stays on the 4. Don't lose it. Don't lose it. Over here, we have less than or equal to, looks like, +8, because that's what happens when we say 13 minus 5. Now, good problem here because it's going to nicely divide out. And we're going to divide by -4 both sides. All right, just go ahead and clean it all up. What happens, folks, when we divide by a negative out there? Think with me. The signs change. And when the signs change, the inequality has to shift position. So in other words, our n, our -2, this is going to become greater than or equal to -2. Now, if I put a -2 in there, it works. It says it's got to equal to. That's why I know that -2 is important because that makes it equal. The question is, give me a number that's greater than or equal to, well, we don't want to worry about equal. Let's go for greater than -2. How about 0? If you put a 0 in here, you get 0 plus 5, which is 5, and 5 is less than 13. So that checks out, my friends. Like I said, pick a number. It doesn't have to be a fancy one. It doesn't have to be a messy fraction. Just give yourself a nice integral value. In that case, we can use 0. Nice, sweet number there, all right? Let's take a look at our next problem here. 3 times a number less 40 is at least 8. Oh my goodness, that's the other one. We had at most just a minute ago. Now we got at least. That means 8 or more. 8 or more, all right? So keep that in your mind. Now let's talk about what we're going to do. It says first define the variable. We're going to do just that. We're going to say n is this number, this nebulous number we're looking for. And it says if we take 3 times that number, and, ooh, what is less 40? Some of you are always saying, Ernie, that's supposed to be 40 minus 3x, or 40 minus 3n as the case is here. No. Look. It says 40 less. No, it says number less 40. So we're going to subtract the 40 this time around. That's the way it works. Now, at least means, what did we just say? Greater than or equal to. All right, in other words, least is the lowest we're going. We want higher. All right. So let's do it. This quantity is going to be greater than or equal to 8. All right. So in other words, this time it's a minimum. Puts this in a maximum role, okay? Well, this one's not so bad looking, is it? Everybody says, no, it isn't, I don't think. Let's add 40. Let's add 40 to both sides. And nice thing here, we don't have to worry about the switching signs, but we got 3n. Over here we got 48, and we still have this greater than or equal to. Now folks, I just basically I haven't done anything but added 40 to both sides, so that does not switch or shift the inequality. Only time you shift an inequality is when you divide or multiply by a negative number to both sides, all right? Multiplication and division. And this was actually positive anyway, so in most cases we probably weren't even worried, but I just wanted to make sure we understood when we changed the order of that inequality. Now, let's go finish it off. Let's divide by 3, and I'm seeing that n should be greater than or equal to 16. Now, I know if I put 16 in there, I get the equal part, all right? So that's important. I know I've got to have that equals to there. But the question is, find a number that's greater than. How about it? 17. Why not? The next number on the line. 3 times 17 gives me 51, and 51 minus 40 is 11. And folks, 11 is definitely greater than or equal to 8. All right? So that's your values there. That checks through for us. And again, this is what we're applying today. We're going to look at some numbers, and we're going to get beyond the numbers here in just a minute. We're going to actually say some real world situations, we like to call them there, real world problems or data and stuff. Let's take a look at this next one here. It says 3 times the sum of a number and 7. Now that tells me, once I name my number, we'll call it n. N's such a great thing to add for a number. The sum of a number and 7. I get the feeling reading this one, I feel like we're wanting to add n plus 7 first, and then multiply it times 3. That's what we're going to go with, all right? And it says is greater than. That one's straightforward. Do it. Right, there we go. 5 times the number less. There's that thing again. 5 times the number, just minus 13. And again, you say, Ernie, when do we switch that? I know my teacher taught me in algebra or pre-algebra that I had to turn them around a lot of times when it came to subtraction. This says if it had been less than, okay? If it had been 5 less than 3 times, something of that nature, okay? 5 times, we'll try it again. Let's move on, all right? Let's go ahead and get to the problem. I get a little tongue-tied there on these things. Let's go ahead and distribute those through. We got 3n plus your 21 greater than 5n minus 13, all right? That's where we are. We distributed, by the way, all right? Nothing like getting a little tongue-tied there, trying to get those things twisted around. It's hard to talk sometimes while you're live on the air or not on the air even, whatever. All right, let's see happening. We've got minus 5n. I'm going to do that first. I'm going to move the n's to the left, let them get together. And if you'll notice something here, I now have a negative 2n, which should set off bells, signals, whatever, whistles in your head saying, something's going to happen. Something's going to happen because we got a negative 2n over there. That's going to be important to us. Let's now subtract 21. And you say, my goodness, Ernie, that number's getting big. Well, it's big and negative. Let's see, we got a negative 2n over here. And those add up to give us, looks like 34, and it's going to be a negative 34. So what we're going to look at here is that we want to pick up and say, we're going to switch this thing around. So we're going to say n becomes less than, remember the inequality shifts as do the signs. So we're going to have n less than 17, where that's going to give us what we're going to go with. Now, does it check? Does it check? I'm looking for numbers that are less than 17. Well, first of all, a quick look at 17. 3 times what we got here. Looks like 3 times, 17 plus 7 is 24. That's going to give us 72. Over here, that's going to give us 85 minus 13, which is also 72. All right, when we substitute the 17. Now, keep in mind, we don't want the equals to this time, so that's not included there. But we still got our boundary. We're good on that part. We're good on that part. Now, let's pick a number that's less than 17. Let's go real easy. Let's do 0. How about it? Let's put in 0. So we put in 0 here. 0 plus 7 is just that. 7 times 3, 21. Keep that number in your head. Over here, put a 0 in. We get negative 13. Folks, 21 is quite a bit larger than negative 13. So the less than does check. And again, be careful. if you had not done the shift correct on the inequality, you would have spotted that when you check it. You would spot that when it checks, all right? So be sure, get that thing going in an opposite direction when you divide or multiply through by a negative, all right? Good job out there, everybody. Let's look at a situation here. Ken wants to drop from 210 pounds to less than 180 pounds. And losing about 2 pounds per week, how long will it take to achieve his desired weight? All right, so let's look at this. He is at 210 pounds at first, all right? That's the situation, all right? And he wants to drop to less than 180. So how long will it take? How long will it take him to achieve his desired weight? So let's look at this. Let's look at this. He's starting at 2,000. No, he's not that big. He's starting at 210. By the way, let's let W equal his weight. No, not W equaling his weight. We've got that already, don't we? What are we looking for, folks? How long? Let's let it be T for time. Let's do T and let that equal time. That's why it's nice to define our variables, okay? Sometimes we already have. The word weight popped up here, but we already know where he's going, all right? So what we're going to do here, what we're going to do basically is say he wants to get to 180, and he's got to lose 2 pounds a week. So he starts at 210. He's going to lose 2 pounds a week. Call it T for time. We don't know how many weeks. That's what we're trying to figure out, how many weeks it is. And our goodness sakes, what are we going to end up with? He wants that amount to become what? Less than 180. You got it? Everybody see it? Again, we started here at 210. We're losing 2 pounds a week. That's the subtract part. And we want to eventually be less than 180 by doing this process. Okay? So let's see what's going to happen. We're going to, first of all, remove that 210. Let's subtract it. And when you do that, my friends, please make sure you leave that negative 2t. That negative has to be there. It's going to be very important, very important. We have less than negative 30. You say, Ernie, there's a lot of negatives there. And that's okay. That's okay. Because when we divide negative 2 into negative 30, which we're going to do right now, let's do it. That inequality is shifting. And dear friends, good news. We have positive 5, positive 15. We got a positive number, all right? And that is how many weeks it would take. Now, notice it would take 15 weeks to get to 180 if he averages 2 pounds a week, all right? But this says to get under that 180, all right? So it's going to take a little bit more, maybe 15 and a half weeks, maybe 16 and a half weeks. 16, you get the idea. Anything bigger than 15. Now, obviously, he can't keep losing at that rate forever and ever because he's just going to blow away, all right? Yeah. But the idea is he's just wanting to get down there, so he's literally going just a little bit more than 15 weeks it's going to take him. And at that point, it's his choice how much further he wants to reduce his weight, all right? And there comes to a point where everybody says, you know, you just don't get any more returns. It kind of stops. It kind of stops. So there we have it. There we have it. Now let's take a look at a little geometry situation here, all right? An angle is acute. That means measures less than 90 degrees. Also has to be positive, but we're not going to worry about the zero end of things, all right? We're going to just basically look at it and make sure our A value is going to give us a positive value in the end, all right? So we'll talk a little bit about that. But it says an angle is acute, measuring less than 90 degrees. It has a value of 3a minus 15. All right, so let's see here. 3a minus 15 is your angle. We've already basically defined that. A is just some value. All right, in this case, A is just some number we're looking for. So let's see. We're going to take this 3a quantity minus 15, which is our angle. All right, and we're going to make it less than 90. Okay, less than 90. That's the acute angle situation. Well, you say, well, that's not so hard. It really isn't. If you know what this means, measures less than 90 degrees. Well, there you have it, all right? So let's see what we're going to do. We're going to add 15 both sides. That's going to give me 3a. Underneath that, I'm going to add those together. I'm going to get 105, all right? And now, oh, yeah, what's in between it? How about a less than? Still got a less than. Doesn't change. Doesn't shift on this one. Let's divide by 3. And you know what we're going to get? We're going to get A less than, how many times does that go in there? Everybody on it? How about it? 35, I believe. Gives you 35. Now, what that tells me, any number less than 35 will make an acute angle happen here. You see, if I put 3 times 35, I get 105, subtract 15, I'm at 90. But I'm not having an equals to here. So it is important. It is important whether we put that equals to or not, all right? So therefore, we are picking some sort of number. It could be an integer. It could be even 34 and a half. 34 and a half is still going to work for us, okay? It's going to take this thing down just enough to be under 90, okay? So there you have it. Nice little application, geometry world, all right? Now, I have students all the time who want to know, how much do I have to make on this test to get a B, or how much do I have to make on this test to get an A if I've got these scores already? So here's what we're going to do. We're going to look at this thing. It says Jim's scores on big test are 85, 72, 90. It says what score must he make on the next test? So folks, we're going to let X be the score of the next test, all right? That's our starting point, all right? According to this, he has already banked 85. By the way, what's an average mean? What does it mean to average? It means add all the grades and divide by the number. Well, in this case, he's got 3, but he's going to have a 4th one because this is the 4th test. And he wants to get an 84.5. Well, he almost made that on that first test, but then he had that 72 that kind of messed things up, looks like. So what we're going to do, we got to maintain. You say, why did you say 84.5? Why didn't you say 85? Because in your school system and everywhere, your computer will round up at 84.5 and bump it up to 85, and that's how you get a B. So students know, hey, shoot for that 84.5, you'll be all right. You're going to be all right. So let's see how we're going to do that. We're going to take 85, 72, and we're going to add 90, and we're going to have our missing guy right there. And we're going to put it divided by 4, because that's how we get an average. Add the 4 grades together, divide by 4. We want to shoot for that, but we actually don't mind if the average comes out to be greater than. And greater than or equal to, he can squeak by at 84.5. So we're going to put greater than or equal to. So that would be the one he must make at least that. If he makes more, life is even better, all right? So let's take a look at this thing. Let's take a look at this thing. First of all, let's do a little addition here. And tell you what, I think we're running on time here, so let me go ahead and buzz in on our calculator. Let's get those going. We got 85. We're going to go ahead and add them together. And this is one of those times where you would probably do this on a good old class test of some sort. 90. And we see what we've got here. We have 247, all right? So I've got 247 plus x, which makes this a lot easier to look at. And over here, I've still got 84 and a half, or 84.5, or 84 and 5/10, however you want to read that. The next thing I want to do is multiply both sides by 4. And as I multiply by 4, the 4s are going to cancel. That's nice. And I'm going to go again, I'm going to get cheapy here. We're going to go to the calculator. Let's do 84 and a half times 4. And we are going to get 338. So again, we're going to multiply. Remember, I put that 4 over there. We got to multiply by that. So what we've got here is 247 plus x will be greater than or equal to, it looks like, 338. Now, at this point, let's bring it right over here. We need to remove 247. We need to take 247 away. So that's what I'm going to do. I'm going back to the calculator. That's why we have technology at times to help me and help everyone here. So we're going to subtract 247 from that and see what kind of score he's got to make. According to this, he's got to be greater than or equal to 91. Okay? So there's the final answer when we subtract that 247 away. Now, that's the minimum. That's the minimum. So you know what? We're going to test real quick. We got just enough time to check this. So let's see. Take 91. We already know the other numbers added up to 247. No need to redo that again. And it might help if we put a plus in there. How about it? Let's try that. 91 plus 247. All right, we've got 338. Let's divide that by 4. Let's see if I can get a 4. Voila! He got a B. He got a B. And everybody's happy and they rejoice and all those good things. So he does. It does check back through. Easy checking on that. Just simply go back through, add those 4 together, and see where you averaged out. Hey, folks, a little bit of application of inequalities today. And I know we all get nervous about those grades. All right, what do we have to make? What do we have to make to get a certain grade? So it's our nature. It's the way we are. Hey, thanks for tuning in this afternoon. It was another great day of specialized segments. We will be back again Monday live for you and another great week of Mathline. Thanks for tuning in today. See you then.